Alright, so sine and cosine graphing worksheet. Problem number 1. Let's graph 3 sine of x minus pi over 6. So in order to do that, we need to think of what we have. We have an amplitude of 3. We don't have any coefficient in front of the x there, so the period is the normal 2 pi period. And again, that's just the amount of time it takes to go around the unit circle. And then the phase shift is going to be to the right by pi over 6. So say pi over 6 to the right. So if I draw my axes here, I'm going to label 4 tick marks to the right of the origin as the full length of my period. So I'm calling that right there 2 pi. And then that means these pieces here will be split up incrementally. This distance in the middle is half, so that's pi. And then, of course, this one is half of that, so that's pi over 2. And 3 pi over 2 right there. Now, my amplitude is 3, so I'm going to be going up to a positive 3 right there, and down to a negative 3 right there. And everything is shifted to the right by pi over 6. So I need to find a way to indicate pi over 6 on here. Well, how many pi over 6's go into a pi over 2? Well, if you think about it in terms of pi over 2 being a full quadrant of the unit circle, well, there are 1, 2, 3 pi over 6's that fit into it. Another way of saying that is, what is pi over 2 divided by pi over 6? Well, pi over 2 divided by pi over 6 is the same as multiplying by the reciprocal of pi over 6, which is 6 over pi. Your pi's cancel, you're left with 6 over 2, which is 3. So I need to split each of these up into 3 sections if I want to shift this graph to the right by pi over 6. And let's give ourselves some negative stuff as well, just to fill out these axes completely. Alright, put these tick marks in, and we should be good. So, if you think about the sine graph, the first value on a sine graph is 0, because it is the y value. So, I would normally start right here, but everything is starting pi over 6 to the right, so I have to start right there. And then I would normally end up at my maximum value, which is 1, but we're multiplying that by 3, so I'm going to hit my maximum value at 3, and I can put that there. But wait, every single point needs to be moved over pi over 2, so that point actually needs to be right there. So I'm going to put my point right there, and now I'm going to keep running through like I know how to do. And I'm going to work backwards as well. And notice that at every single spot, I'm always pi over 6 to the right of one of those pink tick marks. And I can sketch this in like that. And it looks pretty good. And I did more than one period, but I filled the axes, and it looks pretty nice. Can you hear how cutely my dog is barking? She's doing a little woof. Yeah. Let's do the second one now. So, negative 2 cosine pi over x plus 3 pi. I went into this one very much in depth in the last lesson video, so the secant and cosecant graphing lesson video, which is day 7. So we'll just hit the main points right here. Main thing to think about is if you want to graph this function, you should factor the inside. So I'm sorry that this is all blurry, but look, I found a way to make it not annoyingly blurry. So we again looked at this in depth in the last lesson video, day 7, but we'll run through the basics here real quick. In order to understand what is going on with our transformations, we need to factor that pi out of the inside. So we'll be left with an x plus 3 there, and that's inside our cosine function with a negative 2 out front. So my amplitude is going to be 2. My period is going to be 2 pi divided by pi, the coefficient on the x term. So I'm going to be left with just 2. And then I'm going to be adding 3 to this, that plus 3. Now that it's factored, we can see will give us a phase shift of 3 to the left because it's plus 3. But since my period is 2, a phase shift of 3 to the left is absolutely equivalent to a phase shift of 1 to the left. So all I need to do is shift it 1 to the left because the 3 includes more than one full period. Again, that goes into more depth in the lesson video, so if you want to watch that, please do. But now I'm just going to label my axes. So I'm going to go to a positive 2 and a negative 2 there because of that amplitude of 2. My period's 2. So what I'm going to do is I'm going to label this out here as 2. We'll have 0, the origin right smack dab in the middle. That'll make that a 1 right there. Will give us a 1/2 and a 3/2 right there. And then similarly in the negative direction. Now, I'm only going to be asking you to graph at least one full period, but if you show me more, then that's great. So our phase shift is 1 to the left, so instead of starting with an x value of 0, I'm starting at an x value of -1, and since I have that -2 in front, and instead of starting at a y value of 1, I'll be starting at a y value of -2. So my first point is going to be right there, and then each little quarter increment of the whole, which is really equivalent to 1/2 unit, each 1/2 unit I'll be jumping to a different end of my graph, going between the minimum, the 0, and the maximum, and I'm going to continue to oscillate back and forth between those two values, and I should end up with a graph that's going to follow this pattern. So it should come in curvy, go out curvy, and look something like that. And we will call that complete. Okay, problem number 3, dealing with a sine graph now. Let's go ahead and see what we can do. I know my amplitude is going to be 1/2. I know my period is going to be 2 pi divided by 2 from that coefficient right there, which leaves pi. And I need to factor this inside to determine what my phase shift is. So I need to factor out that 2, and I'll be left with pi over 2, just like that. And then I'll still have my sine and my 1/2 right there. So, forgot to write my parentheses. There we go. So, my phase shift will be pi over 2 to the right. My period is pi, so I'm going to label this point as pi, which makes halfway pi over 2, and a quarter of the way pi over 4, and 3/4 of the way 3 pi over 4. And similarly in the negative direction right there. What I'm going to do, instead of making my graph super tiny and smushed, is I'm just going to label this as 1 up there, making the halfway point halfway, and label this as -1, again making the halfway point there actually have a value of 1/2. So let's do what we do. Sine starts at 0, so I typically would get the point 0, 0, but everything's shifted to the right by pi over 2, so I'm going to put my 0 there, and then sine goes up to its maximum value, so after one tick mark it should be up at its maximum, then it's going to come back down, and we can repeat this pattern working our way backwards as well to get all of these points. And there we go. And we can sketch that in just like that. And how many periods have we shown? Well, just think about tracing it. There would be 1, and there would be 2. So we showed 2 periods of this sine graph. Alright, last one we're graphing on our own. Amplitude is 1 because there's no coefficient in front of the function sine. Period is going to be 2 pi divided by that coefficient of 4. So 2 over 4 is the same as 1/2, so the period is pi over 2. And then there is no phase shift But we do have that plus 1 there, which is a vertical shift, vertical translation of up by 1 unit. So the very first thing I'm going to do is I'm going to think about the fact that normally a sine graph has an axis of symmetry running down the middle. Well, I'm going to shift that axis of symmetry up by 1, because that's what this plus 1 at the end does. So I'm going to dash in a line of symmetry with the y value of 1. That will make it easier to do everything else. And then I know that my period is pi over 2, so again I'm making 4 tick marks over and labeling it pi over 2. Split it down the middle, that'll give us pi over 4. Split that down the middle, that'll give us pi over 8. And 3 pi over 8 right there. And then again, same in the negative direction right there. Okay, well, let's then now piece this together. My amplitude is 1, so I'm going to be going to a maximum of 2. Let's do this. No, it's too late to do that. Amplitude is 1, so I'll be going up between 2 and 0, because the amplitude is 1, meaning the distance between the max and the min is 2, but everything's shifted up by 2. So let's piece this together now. All we need to do is graph a normal sine graph, and then we'll be done. So plotting all those points in, it's no different except for the fact that it's been shifted up by 1. So that's that, and I'm done. Alright, now here we're given a graph and we need to write an equation for it. So let's see what we can do. First thing we should determine is, or easiest thing to determine, is the amplitude. Well, it's going from 4 to negative 4. Half that distance, that full distance is 8, so half of it is 4. So we're getting that amplitude, that height of the wave right there from the top to the line of symmetry is 4. So we get an amplitude of 4 there. But what about the period? Well, one full cycle, see how long it takes you to get back where you started before that pattern repeats. Well, look, it goes to 3.14159, which is pi. So our period is actually pi, which means it is half of the normal value, which means we must be going through the unit circle twice as fast, which means when I write my equation, it's going to be y equals, I know 4, and then I'm not sure if it's sine or cosine yet, but 4 times on the inside, I know I have to have a 2x right there. But let's think about the different ways we could write this equation, because there are many different ways. Think about this. That's like a negative sine graph, so I could say negative 4 sine of 2x. That certainly works. What about some other ones? If we erase that and think about, how about this one? How about starting here like that? Well, what graph would that be? Well, that's going to be a positive sine graph. So we could say that that is y, let's change that pen size again. That could be y equals positive 4 sine of 2, but this time we have a phase shift to the, where is that? To the left, which means we're adding a pi over 2 to that, plus pi over 2. And how did I know it was pi over 2? Well, it is half of that pi. So we shifted by pi over 2. So when we wrote it in factored form, we got what we were looking for. Okay then, well, what if we wanted to write it as a cosine graph? Well, if that's the case, then again, we're going to need to think about the infinitely many different ways we could do this, but let's make it easy. So cosine, let's say, starts at its maximum value. So we could say it starts there and comes down there and goes up like that. Boom, that would be one full cycle of a cosine graph. Well, how do we write that equation? Well, it's going to be positive. I do say well a lot. It's going to be positive because it's starting at its maximum, so it's going to be 4 cosine. It's still going to have that 2 in front of the x because it still has the same period. And then what about that phase shift then? Well, it's shifted to the left a quarter of pi. So we need to add pi over 4 to it, and there's a cosine graph. And let's do one last one. Let's say y equals, let's do a negative cosine graph this time. Negative 4 cosine, still going to be the 2x, and let's just figure out what sort of phase shift we need to put into it. So, ignoring that blue one now, let's put this together. Cosine starting at its negative value. How about we choose this one right there? And then that's going to go up and come back down. There's a full cycle. So this one now has been shifted to the right by pi over 4. So all I need to do is then say minus pi over 4, just like that. And I'm totally done. Look at all these different options, different ways of writing the same exact thing. Alright, last problem on this graphing worksheet. Let's see what we can do. Let's identify that amplitude as 3. Let's identify the period. Maybe it's not as easy this time, but maybe let's say, okay, well if I go from peak to peak, because that's where we go to school, from peak to peak, well, imagine that distance is the same is that distance right there. It's just shifted to the right a little bit, and that distance is pi. So again, just like the last one, our period again is pi. So we need to then write some functions that model this. So just like in the last one, we'll come up with a few different ones we can do, but let's go ahead. How about we say we'll do cosine first. So here's a cosine right there. It is going to come down and go back up and go a little bit to the right, just like we found our period. So we need to figure out then, what is that phase shift there? We need to figure out what that is. Well, can you picture how the fraction of the whole big section this is? Well, to me, it looks as if that is 1/4 of that big section, which means there are 8 of these little quarters in that full pi, which means that this has been moved to the right by pi over 8. So, if we write it as a cosine graph, we get y equals cosine lies already, y equals 3 cosine of, what's the phase shift? Well, wait, before we do that, what's the period? Period's 2, which means, I lied, the period's pi, which means we divided 2 pi by 2, which means I need that 2 there for my appropriate change in period. And then I've been moving it to the right by pi over 8. So I need to subtract pi over 8, just like that. Okay, well that's one option. What else could we do? How about we try some form of a sine graph, and then we'll just do 2 for this. So let's think about this right there. That is roughly 1 full period there. It's a sine graph. It's a positive sine graph. So I'm going to write it as y equals 3 sine of 2 times x. And this time I'm pi over 6 to the left, so 2x plus pi over, I said pi over 6, I'm going to say pi over 8. And there you have it, 2 totally acceptable answers for this graph.